Hey, Sunshines. So we are going to talk about lines of symmetry. So to start off with, we have a do now. So we're going to reflect the figure over the y-axis, which is this pink line here, and see what happens. So this point here on the top is on the line, so it stays put. This point over here, 1, 2, 3, 1, 2, 3. How about that? I landed on another point, which means this point is going to reflect back over here. And one, oops, one, one. So these 2 points reflect onto each other. 1, 2, 3, 4. 1, 2, 3, 4. So these 2 points reflect onto each other. 1, 1. These 2 points reflect onto each other. 1, 1. These 2 points reflect onto each other. So all of the points reflect onto another point. And so I land all of the points on this side landed on the points on that side. So what happens is that it looks exactly the same. So that's because it has symmetry. The definition of symmetry is when a figure maps onto itself. So what that means is after you do a transformation, your image is exactly the same as your pre-image. So it's in the same position, it looks exactly the same. The only change is that if you had the points labeled, if this was A prime, if this was point A, then A prime is over here. If this was point C, then C prime is over here. So the names of the points are allowed to change as long as every point lands on top of another point, which is what happened when we did our tree. So lines of symmetry are the lines over which you can reflect a figure and it'll map onto itself. So our tree, the y-axis was a line of symmetry for our tree. So for this rectangle, I have a line of symmetry here, but I also could reflect it the other way. I could reflect it over a horizontal line too. Now the star here actually has a lot of lines of symmetry. I could reflect it like this, but I could go through any of the points, right? So I could go here or here. So there's actually a whole lot of lines of symmetry that I could do. So I made the first line red so that it's a little easier to count off. There's 1, 2, 3, 4, 5, 6, 7 lines of symmetry for this little star here. Because now I'm back to my original line, so we don't want to count that. We don't want to count these again because that's just the other side. So this first one only had 2, but this one has 7 lines of symmetry. And it's a 7-pointed star because there was one line for each point, one line for each. There was one line for each exterior point. There's also a line going through each uh, concave point. So I want you guys to fill in these 2 shapes. Pause the video and try these out. All right, so our crescent moon here has one line of symmetry. I could fold it over here, but any other direction and that point isn't going to line up to that point. The circle is a little bit of a trick question. It has infinitely many lines of symmetry. You can draw a line anywhere through that circle and you're always going to be able to line it up. Uh, so now for the alphabet, oops, it's not the So the letter A has a line of symmetry here. The letter B, it depends on what font you use, but I'm going to call this a line of symmetry, even though depending on the font, the top of it might be too small, so it doesn't really line up. I also didn't put it in quite the right place. I'm going to put this one here because I know a lot of you guys do, but there's definitely a fair argument for there being no lines of symmetry for the letter of B, depending on your font. So I want you guys to try out the rest of the alphabet, and then I want you to try writing the definition of symmetry in your own words instead of just my rather mathematical, fancy vocabulary definition. I want you to explain what symmetry means to you.